let's talk about high pressure liquid chromatography, or HPLC. So basically you inject your sample plus a solvent. It goes through a packed column, which can be in an oven, and then it's detected. So you're going to select the solvent and solvent gradient, as well as the column and detector based on whatever solutes you're trying to measure. And this is pretty high pressure. It goes up to 1,000 bars of pressure. One of the more common detectors is a UV, where you have basically a miniature UV instrument stuck onto the back end as a detector, and so your sample is flowing through, and then the light goes through. And you can also have a mass spec. You can have all kinds of detectors, depending on what your solute is. So, all right, in order to increase separation efficiency, you're going to increase the rate of solute equilibration. And so the way to do that, or an easy way to do that, is to decrease the solid phase particle size. So something between 1.7 and 5 micrometers is pretty common. And that decreases the average pore diameter, and also increases the surface area that's available for sorption or whatever partitioning reactions are going on. You can also increase the pressure to increase separation efficiency. So your columns are going to depend on the application. Microporous silica is really common, but you can also have that derivatized with something like C18, so a shorter hydrocarbon chain. You can have all kinds of things. And your solvents are really going to depend on your solutes, what you're trying to measure, but you could either have an isocratic elution where you have one solvent the whole time, or you can have a gradient elution where you have a continuous change of the solvent mixture according to time. And so it's a mixture of solvent and it changes in time.